Okay, 9.3. So continuing on with arithmetic sequences. I'm actually going to run through some of the examples here. We're basically doing a sum. So this is the formula. 2a plus n minus 1 by d. It's on page 335. So to explain it, you don't have to worry about that. Right. So if you're given a basic sequence 4, 11 plus 18 plus 25, a is 4, d is 7. Sub it in. If you want the sum of the first 70 terms, 70 over 2 by 2 by 4, because 4 is a, plus 7 minus 1 by d, what we're putting 7, 7t minus 1 by 7, because that's d. Calculator does the rest. That's basic. Now, example 2 on page 335 is the one I'm very interested in. Okay, so basically what they're saying there is when someone's born, €50 put in, and they put in an extra tenner each year. Yeah, so 60, 70, so on, so forth. Yep. Now, when you're born, what age are you? 0. Okay, I'm going to point out the inaccuracies of this. First of all, let's just say A is 50, D is 10. It goes up by 10 each year. Okay, so that's how much extra we're putting in. So in this case, it's gone from 50, it goes to 60, goes to 70, goes to 80, so on and so forth. So if you were to say how much money will they have, so the difference between what they're putting in each year is 10. Yeah, simple. T2 minus T1. Not sure what I was waffling about there. Okay, the formula. Always plug in the formula when you can. N, we don't know what it is yet. 2 by a, that's 100, plus n minus 1 by 10. We can always tidy this up. 100. That's going to be minus 10, so let's skip. That's 90 plus 10n. Now, read the wording of this question, the part 2. Part 2 says, the total saved after 21 years. Now, you've got to remember, 0 to 1 is 1 year. So 0 is taken as the first year, as a sequence. 1 to 2 is taken as the second year. So that's why it's not like before when we did a plus nd. So you can use this formula, and that would be s of 21 is 21 over 2 by 90 plus 10 by 21. Okay? Note, if they said, how much will she have at her 21st birthday? Yeah? Well, let's explain this too. How much will you have at your second birthday? Okay, so this is going back to here. This when you're 0, 1, 2. Okay, if we were to apply the logic of s of 2, so the second birthday, 2 over 2, 90 plus 10 by 2, that is 1 by 90 plus 20, that's 110. But that equals how much they're going to have after their first birthday, because it's begun at 1. The book doesn't explain this. So how much would you have after 21st birthday? Just 22 sequences in there, because 0 is the first one, so that's 1. So you'd have to go 1 higher. It's not like there's no formula like the previous time. So you go 22 over 2, 90 plus 10 by 22, and that will give you the correct answer. Difference, how much at 21st birthday, and this is after 21 years. So that's saying at the end of the 20th year, basically, because that has been 21 years. That might sound complicated. You're not really going to get asked that in the book. Where you're going to get asked that is in papers. And we like to prepare you for that type of stuff. Now, example 3, good example. N squared minus 4n. All you got to do is s of n minus 1 will always give you t of n. It's the difference between two sums. The difference between t3 and t2, or s3 and s2 is tn. So you just sub it in. easy, n squared minus 4n minus, and this goes n minus 1 squared, n is replaced with n minus 1, 4n minus 1, this is algebra. Tidy all of that up, and that's going to go to 2n minus 5. Now, see, it's a geometric or arithmetic, you're always going to go tn minus 1 equals to constant. Yep. Like the difference was 7 in the or 10 in the last one, it's got to be the same each time. Constant. So if we're looking here, that's going to be 2n minus 5 minus 2 bracket n minus 1 minus 5. Hopefully it equals to constant. It equals to 2. So it is arithmetic. Okay, simple. The last one that I'm going to run through with you is example 4 is quite explanatory. It's when you see the sigma thing. Sigma equals S of n. That's all it does. So let's say we're given the following. Sigma n or equals to 1, 3 or minus 5. Now we're used to dealing with n. Okay, so all this is saying at what term of n does this sequence equal to 90 for S of n. So first of all, go. If I sub in 1 first, that's 3 by 1 minus 5. That's going to be minus 2. Put in 2 for it. That's going to be 1. Yes. And that's going to be, yeah. If I go again, it's 9. So the difference is 3 each time. So A is minus 2. D is 3. S of n, simple. N over 2. 2A plus n minus 1 by d. That is n over 2. That's minus 4 plus 3n minus 3. And all of that is going to equal to 90. Bring up to 2. And that is 180. And that's going to be n by minus 7 plus 3n. That is 3n squared minus 7n. Bring over to 180. And that turns into a quadratic. Okay? Which works out as a book will work it out for you there. Okay, I'm not bothered doing it here. And the last one, if it goes like this, 8, 1, that basically means find S of 8. That's all they're asking you for there. Like, if you look at your book here now. So running through some of the questions. Question 6, for example. It's got E 6, 1. That's find S of 6. All you've got to do is find A and find D. That's it. That's it. It's really, really, really straightforward. Question 10. In an art class, the student experiments with dream catcher using rings, blah, blah, blah. So hippie stuff. We wish us to design a pattern. How many rings will be needed for design 10? Okay, how many rings in total need to be done? You count up in the number 1, you get our A. You count in number 2, now you got your D. And then it becomes S of, or how many how many rings will be needed for design 10? And you know the formula for this. So how many rings, so design 10 would be T10, design 20, T20. How many rings in total to all 20 designs? S20. Okay, straightforward enough. For the 5th years who are meant to be doing this, I want you to do question 1 to 8, and then the next night 8 to 16. Okay, get through it as much as possible. 6 years, just do what you want.